Hello, today's video is going to be about transformations of exponential functions. So in our last lesson, we discussed the parent exponential function, and that was just this b to the x power part. So everything else around that is a transformation of some kind. So let's take a look at what each of these pieces mean. The first part we're going to look at is h. So this minus h over here. H represents the horizontal shift. So this is moving our graph left and right. And it's kind of the opposite of what you would normally think. A positive h, so if this is a plus sign, that's going to shift our graph to the left. And a negative h, if this is negative like it is there, that shifts our graph to the right. Now K, this part out on the end, that is our vertical shift. A positive K shifts our graph up, and a negative K shifts our graph down. Then we want to look at A. If A is negative, so if it's positive, nothing changes. There is no transformation. But if A is negative, then the function is reflected across the x-axis. And finally, so we've taken care of the sign of A, whether it's positive or negative. So now we're just looking at absolute value. So we only care about the actual number itself, not whether it's positive or negative. And if that absolute value, if A is greater than 1, that represents a vertical stretch. So picture grabbing the graph by the top and by the bottom and stretching it out. And then if the absolute value is between 0 and 1, so most fractions and decimals, but there are some that are bigger than 1, this is a vertical compression. So you would put one hand at the top of the graph and one hand at the bottom and squish the graph, compress the graph. So I'm going to look at number 4 with you because it's the hardest of those first 4 problems. The first thing we want to do is identify the parent function. And the parent function is only x and the big number with the x. So 5 to the x power is our parent function. And everything else, so the 1/2, the -4, and the -2, are all transformations that we have to talk about. It asks us to list all the transformations that happen to this function. So first, let's look at the 1/2. That is in the position of A. And it is a positive number, so we don't have to worry about a reflection. But we do need to figure out if the absolute value of 1/2 is larger or smaller than 1. 1/2 is less than 1. So that means that we are going to have a vertical compression. So this is a vertical compression by 1/2. So that takes care of the 1/2 part, but now we need to do the -4 here. That is in the position of H. So on our notes, we're going to look at what it says about H. That's the horizontal shift, and this is a negative, this is a minus sign, so that means it's going to shift right. So this is going to shift right 4 units. Then we need to look at that -2. So we've done the -4. Now the -2 is in the position of K from our formula. K is the vertical shift, and a positive K shifts up, a negative K shifts down. So this -2 is going to shift our function down 2 units. And that is all of the transformations for this example. So now we're going to skip down to number 6 and work on it together. I skipped number 5 in the examples because number 5 is easier than number 6, to be honest. So I believe you'll do fine doing it on your own. But we're going to do number 6 the same way that we were doing yesterday's functions or the last lesson. So you're going to graph these using your calculator. I'm going to show you on a TI-84 because I think Desmos is pretty easy to use. The TI-84s have a few more steps. If you have any questions about how to use Desmos to do this, you can review yesterday's video or the last video that we did over exponential parent functions. All right, to graph this on our TI-84, we are going to click y equals. That's the top left gray button on your calculator. Then we are going to do 1/3 to the x power minus 2. Then we're going to click graph, which is the top right gray button, and get a rough idea of what our graph should look like. Then I want us to go to our table. And in the table, something you need to be aware of is that when you go toward the positive direction, these numbers get really tiny or really close to 2, -2, and then they turn into -2. This is deceiving. Your calculator is rounding to -2, but in actuality, y equals -2 is the asymptote for this function, and our function is never actually going to equal -2. Your calculator is just rounding, and you need to understand that. You need to remember that that's not actually at -2. It's just very, very close. So let's go back up to -2, where x equals -2, and that's the first dot that we can plot. That's the first point we can plot on our graph. We're going to plot -2, 7, -1, 1, 0, -1, and then I'll come back to you. Then we'll look at what's next. So again, those points from our calculator were -2, 7, -1, +1, and 0, -1. Now, we know that our function is going to get really close to -2, but never touch it. That's the asymptote that we had. I decided to show that a little differently. Okay, so our asymptote is at y equals -2, and we know that from looking at our table. Our table showed us that our values got really close to -2, but they're never going to touch it. So we have these 3 points, and we know the shape that our graph is supposed to be. So we can place our line on our graph now. So let's look at our characteristics. The domain is going to be the same as it was yesterday. For all exponential functions, the domain is just all real numbers. The range, however, in this problem is going to be y is greater than -2. Yesterday, our function was all above y equals 0, which is the x-axis. Today, our function is above the line y equals -2. So that's why our function will be, or our range will be y is greater than -2. There will be some cases today, because we are doing transformations, where our graph might be down here. And in that case, our range would be less than something instead of greater than, because the values are all below a certain line. All right, so in this one we have as x approaches positive infinity, f of x approaches what? So we are looking at the right side of the equation because we want positive, as x goes to positive infinity. We want to know what this equation is doing vertically. So is it going up, is it going down, or is it approaching a certain number? And it is, in fact, approaching -2. Now, as x approaches negative infinity, the left end of our graph, our line is pointing up, and so that is going to go to positive infinity. Our y-intercept, on today's work, this can be any number. This might be really big, it might be a decimal, it might be anything. So I would encourage you to use your calculator to just look at the table and find the value where x equals 0. And that's what your y-intercept is going to be. Your asymptote is going to be the line that it never touches, so y equals -2. Something I'd like for us to pay attention to is that these values, so here's -2, -2, and negative 2. And you'll also notice that we have a negative 2 here. This negative 2, our K value, is going to tell us about our range. It's going to tell us about one of our end behaviors, and it could be either one depending on whether it's growth or decay and if it's reflected or not. But one of these end values will be your K value. And then it will also be your asymptote. So just pay attention to those commonalities. That is all for today's video. Thank you for watching, and I hope you have a great day.